Hello class, so we're going to take a look at implicit differentiation, and this is how we derive equations that are not functions. So when we've taken a look at a lot of our equations, you've noticed that many times they pass the vertical line test, where no matter how many times I hit the graph, it's only going to hit once. We're going to start to take a look at different curves. So here are the rules that we're going to take a look at. This is on your note guide. So step one says that we need to do this anytime we are not working with a function, and we are also going to do these for related rates, which we are going to take a look at in the next section. The first step is to differentiate or take the derivative of both sides of the equation with respect to one variable. So most of the times we'll do these with the x variable, also with the t variable in the future. Once we do that, we're going to look at step 2, which says when the variable in the equation is different from the variable in step 1, multiply by the rate of change of expression. I will show you what I mean by that in a minute. But the key rule is stated right here. When you're taking the derivative of the variable y, in most cases, we are always going to want to make sure that we add dy dx to the equation, and I'll show you exactly where to do that. And finally, the last thing is to group all of your terms and to factor things out so that we can get the derivative necessary. So let's go ahead and take a look at our problem. And as you can see, this right here is not a function, right? So if you take a look at this graph, you see that I have multiple y values for our different x values. So we're going to take a look specifically at 2, 3, and 2, 3 is this point on the curve, right? And it says I want to find the slope of this graph. So what we're trying to do is we're going to use calculus to find the slope at exactly this point, okay? So we want to know exactly where this line is hitting the curve. So let me scoot it down just a little bit. So approximately right there. So the one thing we know is we need to have a negative slope since my blue line is headed downwards. So like it said in step 1, you need to take the derivative, and we're going to combine step 1 and step 2 at this point. So let's take a look at this problem. The derivative of x squared is 2x plus, now I need to take the derivative of y squared. Well, the derivative of y squared is 2y, but since I have a y, I'm going to multiply this by dy dx. This is the first time we're actually taking derivatives with two variables, so we're going to want to make sure that anytime I have a y, I'm going to multiply it by dy dx. And then I take the derivative of 13, which is equal to 0. So like step 1 says, I need to take the derivative of both sides of the equation. So we first did it for this side. Then I also need to take it for the other side, which is at 13. And step 2 says I need to multiply by dy dx whenever I take the derivative of y. Now this question is asking for this question is asking for dy dx. So what I need to do is get this dy dx that we have here all by itself. So we're going to want to try and simplify this so this dy dx is set by itself. Let me get my pen again. So in order to do that, I need to move over this 2x and this 2y. So my first step is there's 2y dy dx is equal to negative 2x. So I subtracted this from both sides. And then to get my dy dx by itself, I need to divide by 2y. So divide by 2y. If you notice, my 2's cancel out, this cancels this out, and we get dy dx is equal to negative x over y. And if we continue with this process, we can then plug in our points 2, 3. So I've plugged this in, dy dx is equal to negative 2 over 3. And this is the slope of the graph at the point 2, 3. Good. So let's take a look at another version of this problem. A little bit more difficult, but keeping the same 3 steps in mind. It says find dy dx, and if you notice, I have now thrown in some trig problems in here. So let's take a look. Well, if I read this, doesn't this say x sine y? Well, anytime I have 2 variables, doesn't that show me I have a product? So if I have a product right here, what rule should I follow? Good, the product rule. And if you take a look, the next 2 terms, we can know how to differentiate those. So let's take this one step at a time. On the left-hand side, I have the first term, which is x, times the derivative of the second, which is cosine of y. Since I took the derivative of a y, I need to multiply by dy dx. Okay. Plus the second term, so since I'm just taking the normal second term, I say sine of y. And the derivative of x is 1, so I'm going to leave that alone. Then I take the derivative of this side, so the derivative of 3y is 3, but since I took a derivative of a y variable, I'm going to multiply it by dy dx. And finally, I take the derivative of cosine, which is negative sine, times my stuff, which is 2x, times the derivative of the stuff, so the derivative of 2x is 2. Okay, so I've done step 1 and step 2, taken the derivative of both sides, and added a dy dx anytime I took the derivative of y. Step 3 is to get all of my dy dx terms together. So if I highlight this, I see that I have a dy dx here, and I have a dy dx here. So I'm going to want to get these 2 yellow terms on the same side and move everything else over. So if I did my math in one step, I'm going to get x cosine y dy dx, subtract this term off, so minus 3 dy dx equals, I want to move this to the other side, so I get negative sine of y minus 2 sine of 2x. Okay, so far this is what we have. And so if I continue this off, I notice that I can factor out this 2y dx and this dy dx. So if I factor that out, I get dy dx times, in fact what's left over is x cosine of y minus 3, which is equal to negative sine y minus 2 sine of 2x. And finally, I need to get my dy dx by itself. So in order to do that, I need to divide by x cosine of y minus 3 on both sides. X minus cosine of y minus 3. And if I finish this off, I notice that this side cancels, and what I get left is dy dx is equal to negative sine y minus 2 sine 2x all over x minus cosine of y minus 3. Good. So once we take the derivatives, if you notice, it becomes algebra again. I'm collecting the like terms, factoring things out, so that way I can get the variables by itself. Let's go ahead and take a look at another problem. So let me continue. And I need to take the derivative of this function. So once again, you see I have trig right here with the sine rule. You also see that I have a product inside my parentheses, so I'm going to need the product rule at one time. And you also see that I have the chain rule right here. So we're going to use all these pieces to find the derivative. So if I take a look at the left-hand side, it's a trig function, so I need to take the derivative of the word. So the derivative of sine is cosine times the stuff, so my stuff is xy, times the derivative of the stuff. So if I take a look at my stuff, I have x as my first term, y as my second term. So I get the first term is x times the derivative of the second, which is dy dx, or the derivative of y is 1, but I have to multiply it by dy dx, plus the second term, so y, times the derivative of the first, well that's just 1, so I'm going to leave that there. And then I'm going to take the chain rule and use it right here, so I get 4 times what's in parentheses, x plus y to the third, times the derivative of what's in the parentheses, which is 1, plus the derivative of y is also 1, but since it's a y variable, I do dy dx. So if you notice, I can't really move anything out yet because I have these sets of parentheses right here, so I'm going to need to distribute in order for me to start pulling things apart. So right here, if I distribute this to here, I get x cosine of xy dy dx plus y cosine of xy. And I also need to distribute this whole thing to here and to here. And so I get is equal to 4 times x plus y to the third times 1. So I'm going to leave that. Plus, I'm going to squeeze this in here. 4 times x plus y to the third dy dx. So that's a third right there. So let's highlight our dy dx's, and I notice I have a dy dx here, and I have a dy dx here, so I need to get those on the same side. And what I need to do then is move these so that these two are on the same side since they do not have the dy dx. So let's do some algebra, and I'm going to move this term right here over to the other side. So I'm going to get x cosine xy dy dx minus this entire term right here, which is 4 times x plus y to the third dy dx equals, and I'm going to keep this term right here, 4 times x plus y to the third, and I'm going to want to move this to the other side, so I get minus y cosine of xy. So now that I have all of my dy dx's on one side and all the other terms on the other side, I can now factor this. So once again, I want to make sure that I factor this piece right here. So let me scroll down just a little bit. So if I factor this out, you're going to see dy dx times what's left over, so x cosine of xy minus 4 times x plus y to the third, close the parentheses, so to the third, is equal to 4 times x plus y to the third minus y cosine of x y. And if you notice, once again, let me extend this page. I need to divide this whole thing by x cosine of xy minus 4 times x plus y to the third So on both sides, I'm going to do that. Cosine of x, y minus 4 times x plus y to the third. This is going to cancel out over here. And finally, I get dy dx is equal to 4 times the quantity. Oh, hold on 1 minute. Times the quantity x plus y to the third minus y cosine of x, y all over x cosine of x, y minus 4 times x plus y to the third. And there's your final answer. So we're going to continue doing this process. So right now, what I'd like you to do is to work on these problems. So in your practice problems, so it's practice problems. Chapter 2.5. And it's page 9 in your packet. I'd like you to do numbers 1 through 9 odd. And then we'll take a look at these on Thursday and see how you guys did. So once again, go ahead and take a look at these problems and try to work out and making sure that you do dy dx every time you take the derivative of the y, and then factor things out so that you can solve for dy dx by itself. Thank you.